In this video, we will use SERIESSUM and LINEST in a Maclaurin series expansion arctangent and its polynomial regression. Here we have an arctangent. We generate the arctangent of its dataset, a array formula, ATAN of these values. And we chart this and regress it to the best fit. We'll use the best fit trend line polynomial. We'll try to make it the r squared equal to 1, 3. That's it. So our polynomial will be degree 3. We will generate the expansion as well in the expansion, and we'll calculate these values using LINEST. So in the expansion, we have here ATAN equals arctangent equals x to the summation of x to the power 2n plus 1 times negative n to the power n over 2n plus 1, which is the coefficient. So our series values of x, and it will be raised to the power 2n plus 1. So our n values from 0 to infinity. And in this case, we cover up to the maximum of our data set, which is 8. So 2 to the 0 plus 1. So our first power is x to the 1. So x raised to the power 1, and so on. So it is 1 and incremented by 2. So we calculate the coefficient, which is our formula, starting with the numerator, negative 1 to the power n. And the denominator, which is 2 to the n, 2 times 2n plus 1. 2 times n plus 1. Now that we have the coefficient, we now generate the Maclaurin series of the arctangent. So it is RA formula, series sum, our x values raised to the power, which should start from 0, no, from 1, because 2 times 0 plus 1 is 1. So we start from 1 and incremented by, the next will be 2 times 1 plus 1, that's 3. So incremented by 2. And the coefficient will be this range. You will notice these values and these values are the same. The function and its expansion are the same. We can show that in the chart. So this series to the chart. You will notice the blue datasets are now covered by the red datasets. We will also include the trend line equation to see if we get the same regression coefficients. We'll use the same polynomial level degree 3 and show the equation. Let's see if we get the same coefficient, regression coefficient. Yes, we do. B0 is 0, B1 is 0.985, B2 is 0, and B3 is negative 0.222, and R squared both are 1. We'll calculate this using LINEST. To do that, we fill up the 1 comma x matrix, starting with the 1 column, the x column, x squared column, and the x cubed column. So here we enter the power, that is transpose up to 3, because it's third degree. Now we generate the 1 comma x matrix, our formula of the x values raised to the power 0. And lock the references. and complete the 1 comma x matrix. So we have the x column, the x squared column, and the x cubed column. Now we can use the LINEST. Data y and data x. That's for the arctan function. And the expansion, which is LINEST, data y, and data x. The values for b0, this is b0, are the same as the red line. Our b1, this one is 0.985, this one is 0.9846, but in the trend line they're both 0.985. Our b2, 0, also 0 in the trend line. Our b3, minus 0.223, and the other one is minus 0.221588. Both are rounded up as negative 0.22. This one is negative 0.223 and this one is negative 0.22. So this shows the use of series sum and LINEST in a Maclaurin series expansion of arctangent and its polynomial regression.